This is dubious code, and today we're going to do a merge sort in Python in about 45 lines of code. So I've got 3 lines up here with a copyright disclaimer because I work at Google, and the rest of it, Python merge sort. So we start out, we're going to make a list of random numbers. This is random integers from 0 to 500. So this is a list comprehension, and we'll copy that to an unsorted list, and then run our merge sort. So if this merge sort works, then the unsorted going through the Python tim sort should match, and if it doesn't, then it won't match. So this is a merge sort. So the way the merge sort works is it splits the list in two, and it keeps basically splitting them until a list has 0 or 1 elements in it. And then it will return the left and right halves of the list, and then see if the left is smaller or the right is smaller to decide whether that will go first in the merged together list. The merge sort is nice because it is a n-logn sort, and it's stable. So here I have a return. I'm going to make this bigger. So here I have a return saying if the list is 0 or 1 length, it's already sorted. And if it's not 0 or 1 length, then we find the midpoint and we split it. So here we make a new left list up to the midpoint and a new right list from the midpoint to the end, and run those through the merge sort. So this is a recursive sorting function. So this is all the splitting the list. If we have a list that comes in of length 10, it'll split it to 5 and 5, and then that 5 will go through and it'll become a 2 and a 3, and then that 2 will go through, become a 1 and a 1, and then return. And then now we do the combining together. And so what we have is a length of I, which is the length of the left list, and j, which is the length of the right list. So as long as we still have a left and a right, we'll go through and we will pop out, and we will pool the left one if the left is less than or equal to the right, in which case we'd iterate our counter. We'd put that left value into our merged list, and we'd iterate our counter. The reason we have less than or equal to here, rather than just strictly less than, is this makes the merge sort stable. So the left will always, if it starts on the left, it'll stay on the left. And if it's not less than or equal to, then we pull from the right. And then we would iterate our j counter, and then we iterate our counter for the full list. And so this continues until one of the two lists is exhausted. And then what we need to do is go through and add everything from the remaining list. So if there's anything left in the left list, we'll go through and add it to the full list. If there's anything left in the right list, we'll go through and add it to the full list too. I'm just getting back into Swing of Python, so I'm not certain that this is as little code as possible. Now that I'm looking at it, I bet I can get away with a list.extend and move a couple of these, but it definitely works because we can run it and the two things are sorted. If I were to screw something up here, let's say I were to iterate the wrong counter, then it wouldn't work. We're not sorted. So that is a simple merge sort. It is a nice sort because it is stable. It's always n-logn. Once again, this is dubious code. Thank you for watching.